Hello everyone, hopefully you're doing well. In this video, we're going to start with chapter 6, normal probability distribution. So in this chapter, it's just the continuity of chapter 5, where we introduced with discrete probability distribution. But in this chapter, we introduced the continuous probability distribution. Most of this chapter focus on normal distribution, which are the most important distribution in the field of statistics. So in this first section, we're going to in this first section, of course, we're going to start with the standard normal distribution, where we would describe the characteristic of a standard normal distribution. We would find a probability of some range of z-scores in a standard normal distribution. We would find z-scores corresponding to regions under the curve representing a standard normal distribution. So let's go very quick in terms of key concept, what we're planning on doing here. We said we present the standard normal distribution, which is a specific normal distribution having the following properties. First of all, a normal distribution has a bell shape, like let's say this is a normal distribution. It is symmetric about the mean, symmetric about the mean. That's what we said, bell shape, the graph. Yeah, the graph of a standard normal distribution is bell shape. So I'm hoping I do it properly, but because usually bell shape, is like we will have a chance to do a lot of. Is that correct? All right. But anyway, it is symmetric about the mean. The mean is mu equals 0, and the standard deviation 1. Remember, we did some empirical rule where you can move one standard deviation above the mean, two standard deviation above the mean, and three standard deviation above the mean. And you can subtract one standard deviation below the mean, two standard deviation, etc. So the sigma equal 1, the standard deviation has a standard normal deviation equal to 1. So in this section, as we said, we develop the skills to find areas or probability relatives frequencies corresponding to various regions under the graph of the standard normal distribution. So, in addition, we find z-scores that correspond to areas under the graph. Okay, these skills become important, as we move forward. Remember, the idea is like we find probabilities, but there are different techniques we can use to find probabilities using tables. So that's what we're gonna do here is using tables. So normal distributions. This is, we said like there are indefinitely many different normal distributions depending on the values used for the mean and the standard deviation. We can begin by, with a brief introduction to this family of normal distributions. We said if a continuous random variables has a distribution with a graph that is symmetric, you know, in bell shape, we say that it is a normal distribution. Okay. So, as you can see, for us, a normal distribution, is a bell shape and it is symmetric. Symmetric about the mean. The mean is fall exactly in the middle. So you can see that curve, it's bell shaped and symmetric. And of course, as I said before, we can move one standard deviation above the mean, that mu minus one standard deviation, mu, no, plus two standard deviation, mu plus three standard deviation. If you miss something about empirical rule, I strongly advise you to go back and watch the previous videos. But for this one, you see, you can move one standard to plus and minus three standard deviation under that curve. So because we can do it for three standard deviation both sides, all right? So, and we said that for the empirical rule, like 68% of the data falls within one standard deviation, 95% of the data falls within two standard deviation, and 99.7% fall within three standard deviations. So don't forget that, because we talked a lot about it. We for this one, for this shape you see here, we won't actually use this formula you see here. I just show you something, but this formula, we're not gonna use it, but we examine the right side of the equations, reveal that any particular normal distribution is determined by two parameters, the population mean and the standard deviation. Because for us, this is how we're gonna do it. We know we can convert any x values to z, okay, knowing the mean and the standard deviation. Then once you know z, we have a table where we would find the corresponding probability. So that's the formula we're gonna use. I want you to bear it in mind. So convert any x values to z using this formula. So this is the formula we're gonna use. Remember, mu is the population mean, right? And we have sigma is the standard deviation, right? Population, of course. And you have x, the x is the values, right? So for example, let's suppose you want to know what is the probability that you obtain a 95 in my final exams, knowing that based on my past test, the average been 85 and the standard deviation 10, right? So at some point you should find that z values, that z score. Then you will see the tables we're going to use for you to find the corresponding probabilities. But also, the major focus, the major focus of this chapter is the concept of a normal probability distribution. But we begin with a uniform distribution so that we can see the following two important properties. The area under the graph of a continuous probability distribution is equal to 1. So the whole area, when we do, for example, the area. Okay, so when we talked about the area, that means the area here, total is 1. That means remember it's probability. So probability is 100%. All right. So for us, we said probability is equal to 1. Okay, 1 or 100%. And we said number 2, there is a corresponding um, area and probability. So probability can be found by identifying the corresponding areas in the graph using this formula. So you can see, remember, if it's uniform, uniform means, let's suppose that, let me show you what uniform means. If you have a graph like this, right? Let's say to find the area, this one looks like a rectangle. What is the formula to find the area of a rectangle? So remember, if you use the area, let's suppose we call this one length and we call this one width. So we know the area at that point would be length times width. So if you know the formula already, because for some shapes, we already have a formula. If you want to find the area of a rectangle, length times the area of a circle is pi r square, right? So you can continue like this. The area of a triangle is 1/2 times base times height, right? So we can go that one. That's what we said. The uniform parts is very important. um a conditions, like we said, like here with this we said the form area is height times width or length times width, but we said a continuous random variable has a uniform distribution if its values are equally spread over the range of possible values. So the graph of a uniform distribution results in a rectangle shape. Of course, we can see that as I just did it here for you to see. In terms of density curve, the density curve for us, the graph of any continuous probability distribution is called a density curve, and any density curve must satisfy the required the requirement that the total area under the curve is exactly 1 or 100%. Of course, this requirement that the area must be equal 1 simplifies probability problems, right? So, because the total area under any density curve is equal to 1, there is a correspondence between area and probability. So we're going to have a chance to see this, but let's go over some examples very quick. Look at these particular examples, because as I said, we're going to move very quick with the examples, knowing that you can also do our best to solve the problems very quick. But let's go first of all with some with these examples, all right, where we said assume that a passenger, okay, we're gonna go with this example. Assume that a passenger is randomly select, find the area that the waiting time is within the given range. We're gonna refer to this, right? Now, the first questions, assume that we're gonna refer the continuous to distribution. So we said, okay, it's greater than 3 minutes, right? So remember, we're gonna say it's greater than 3 minutes would be the first thing to do, right? Okay, we said a probability that x is greater than 3. Remember, if it's greater than 3, what we're gonna do, remember, this is 3, and this one right here, greater than 3, is here, right? So what is greater than 3 is that part. Okay, what is the length? Okay, remember, for us in this case, all right, if you want, now this height is 0.2, remember, and 1, 2, so this is 2. So for us, we're gonna have 2 times 0.2, because for us, the goal is to do length times height. Remember, for us, area is height times width, because width, that's what we said, remember that. So for us, it's 0.4. Now for B, less than 4, probability that X is less than 4. I'm going to erase this, and you can see what we're going to do then. Okay, we said less than 4, this is 4. So remember that if it's less than 4, this is the area we're looking for. Okay, so what is the height and what is the width? So the height is still 0.2. The width is 1, 2, 3, 4. So we're gonna do less than 4. That will be 4 times 0.2. Right, that's give you 0.8. I hope you'll see that. See, between 2 and 3. Now, what you need to see here, when you say between 2 and 3, is it inclusive? Because they don't say inclusive. For us, between 2 and 3, oops, sorry. Okay, between 2 and 3, 2 and 3, this is what you got. Please, what is the height? Because the width still, I mean, it's now is 1 times 0.2, right? It's 0.2, if it's okay for you. Now, for D, we said between 2.5 and 4.5. Now, let's do it. 2.5 and 4.5. So if you go 2.5 should be here, very straight. 4.5 would be here. Okay, look. Now you can count. Now let's see. Point 0.5, 1.5, 2. So we know this would be 2 times point 0.2. Again, that's point 0.4. So that's how I do this one like this to show you sometimes if the shape of if your shape is kind of uniform, then make it very easy for you. You know, make it very easy for you to use those known formula. But you know what? Standard deviation, normal curve. Remember, we're using normal curve because the plan so far would be to go with a table. And we need to understand the standard normal distribution. So the standard normal distribution is a normal distribution with the parameter mu and mean mu and standard deviation equal to 1 and the total area under the curve is 1. Please keep this graph on your mind because we're going to use it a lot to find the probability. Okay, very important. So we can find area probabilities that different areas under a normal curve using technology. That's we call this one a standardized normal table or normal distribution table, or in some books it says table A2. You're gonna find it in your books, of course. Remember you can do that. Technology strongly recommend because you can use your TI-84, TI-83. Nowadays, no one do statistic manually anymore. You can use Excel. So remember in your calculator, if you go math, probability or statistics or distributions, you should find the same thing I showed you, binom. You can also, remember, binomial PDF, I told you how to do it before. So in this particular case, if you use TI-84, when you go second functions and you do vars and you do distributions, we have those like you're gonna see inverse normal, inverse norm, like you do area, okay? And the mean is 0, the standard deviation is 1. Now you only need to know your tails. What would be your x? So if you do this one in TI 83 or 84, I'm gonna put 84 because usually I said 83, 83. Oh, so I think 83 and 84 you do 3 or 84. You can use those type of formulas to find a normal distribution. So that's one of them. You either use or you use norm CDF or PDF because we do both. Okay, so you do PDF, CDF, then you do lower Z, upper Z, okay? Then you do the mu and the sigma. Of course, there is a possibility that you'll find everything. So we're gonna have a chance to practice in a different video on how you use, and how to use your calculator. Look for these videos that I'm going to post about it. So if using the tables, it's essential to understand this point. Table is designed only for the standard normal distribution, which is a normal distribution with a mean 0 and a standard deviation 1. That table is on 2 pages. Like you have one side that give you the negative values of z, and the other side that give you the positive values of z. Each value in the body of the table is cumulative area from the left up to a vertical boundary above the specific. So, for now, I know you don't see it yet. It sounds good, but let's see the tables pretty soon. I'm going to tell you, when working with a graph, avoid confusion between z-scores and areas because z-scores distance along the horizontal scale. So Keep these because I'm just giving you the steps to follow to find probabilities from the tables. But as I said, we're going to have a chance to do it. So cumulative area under the curve, you see here, all we're going to ask you under the curve, when you have it, you can either find, okay, under the curve, when you are on the right, let's suppose you are on the left. That means you're looking for this particular area. Okay. That means you are on the left. On the left, let's say probability that Z is less than Z naught. I'm going to put Z naught for you. Take exactly the probability found in the table when you are on the left. But if you are on the, oh, did I do it right before? No, we didn't do the right. So, where is the right? Okay, no. We need to go for the right. Cumulative area on the, I wonder where is the right? Okay. You know what? We're gonna add the right, If you are on the right, or let me put it here. So maybe I'll have enough space. Okay, on the right, this is what you're gonna have. If you are on the right, for example, so let me move, my line needs to be straight. This line that separates the what you want from what you don't want, we call it critical value. So let's say this is the right. If you're interested to this area, okay, we said on the right. So probability that Z is on the right of Z naught, that means that the number we're looking for. The probability would be 1 minus prob from the table. And between, we subtract the largest from the smallest, all right? So that's what we're gonna do, but this is our tables. It's hard for you probably to see what the tables is exactly, but we can, I don't know if you can read it. It all depends where you are, okay? So this table here, for examples, if they ask you if Z, I'm gonna give you an example. If Z, what is the probability that Z is 1.25, okay? So what the probability is on the left. So to be on the left, what I'm gonna do, Z on the left, you see, 1.25. First of all, I need to identify, am I on the positive or on the negative? In these tables, you see the left side is Z positive. The first column is Z. This is Z. Okay, we're gonna have Z like this. This is the values for Z. And, those, oh, sorry. Okay, so we have Z like this. So those are the positive. What we can do from this one, when we say Z, I'm looking for 1.25. The problem, if you look at on the first column, we don't have 1.25. We have 1.2. This is 1.2. To make it 0.525, I look for this one here. So you see the corresponding probability to 125 would be this value right here. So it is 0.8944. Do you see it? Or let's say if they ask me to do probability, if Z is greater, you see on the right, greater means on the right of negative 0.26. You see, I said negative 0.26. First of all, because I said greater than, that means I need to subtract from 1 the probability that I would find from the tables. Now, let's say we are on the negative side of the tables. Negative side of the tables, remember this, the first column is Z, and this is the additional decimal for Z. Now, let's see. 0.3. First of all, I need to look for 0.3 is right here. Okay. Now make it 6 is here. So this is the values corresponding to it, right? So 0.36 right there. Answer would be 0.3594. Okay, remember, now we need to subtract what we find from 1. So 1 minus 0.3594. This probability is equal to 0.6406. So that's how we proceed to find probabilities from the left and the right. In between, we don't subtract from 1, but we subtract the smaller probability from the larger one. So that's what we're planning on doing. All right. Now, let's see it very quick in some examples because we're going to use these tables a lot. Let me make this one smaller for now, as you see what I was planning on doing, and I'm gonna use this table a lot. Okay, let me put it here. Pass. Oh no, I passed with everything. Let me erase. Can I erase? Okay, I erase. Okay, now this is it. On the left, go in the table, 0.44. So they said on the left. You see, it's on the left side. So probability that Z is on the left of 0.44. What you find in the table for 0.44. Let's do it from this table. Look, remember, I'm going to make this one bigger for you to see. 0.44 is here, 0.4. Going 4. That make it 44. This is the answer right here. Okay. 0.6700. So 0.6700. And this one, you see Z is greater because they said on the right, it is greater than negative 1.04. First of all, because it says greater, then I need to subtract the corresponding probability from 1. So I go back to this table. Remember, we're going to look for negative 1.04. First of all, I take negative 1, 1, 0. Let's make it 0.4. 0.4 is here, right? I go like this. I do this just so you to see, but you don't need to put those lines. Mess up your tables everywhere. So it's 1492. 1492. And if we do 1492 very quick, what we're gonna obtain for this one, I believe is gonna give you 0.8408. 8408. Now let's see between. Look at what happened with between. When we do between, that means Z. Okay, Z is between negative 0.84. I'm gonna put Z between because it's between. You see the shaded area. I'm focusing on the shaded area. Z is between negative 0.84 and 1.28. The first thing is to look for the second probability. So what is Z for 1.28? Because it's the biggest one. So 1.28, 1.2, first of all, this is 1.2. Make it 8 here. 1.28 is this one here. 1.28.88.8997. Okay, that's make it equal 0.8997. 997. Now look for the probability for negative when z is negative 0.84. Negative 0.84, negative 0.8. Make it 4. It's right there. Okay. You see it? Then we put it like what is that again? 2005. Now you can subtract. So when you subtract these, when you do it that way, answer would be 0.6992. 0.6992. Okay, always verify. So what we mean by doing between, when we said between, z is between negative 1.07 and 0.67. So if you want, you can rewrite it as probability that z is less than 0.67, okay, minus probability that z is less than negative 1.07. Okay, if you want to write it that way, that's fine too, because that's the best way to write it. Not to get confusing when we do between. So first of all, you look for 0.67. You go on the tables and look for 0.6. Yeah, 7 is right there. So it's gonna be 0.7486. 60, no, 6 point, what's point again? 0.7486, 74. Okay, now let's go for negative 107, negative 10. Well, I can just continue 10 until we get to 7. This is 7 right here. Remember 7 right here. Okay, so that means I can go all the way down and point 1423. When you subtract these two, what you got again? You subtract these two, answer should be 0.6063. If you use your calculator or Excel, probably it's, the decimal digits might be a little bit different, but at the end, the answer, the first two digits will definitely be exactly the same. Even the first three digits, decimal digits, maybe the fourth one would be different. All right. So I give you an idea on how to do it, but I would assume now the difference between what we just did in these particular examples, you are provided the z-scores. Now we ask you to find the probability. Now, what we're gonna do with the second one here, you are given the probability. Okay, you're gonna do the inverse of it. So let me copy the same table, put it here for us to look at. Okay, I'm gonna just clean it a little bit. Okay, let's clean. Okay. Now, the probability is given. Now, what z correspond to this probability? Exactly, we see. Find the indicated z-score. The graph depicts the standard normal distribution of bone density scores with mean and standard deviation. We have the mean and standard deviation. Now, our goal is to find z. We are on the left. Remember, when you are on the left, look at the probability exactly corresponding to this one. So our goal here, sorry, is to go inside of the tables. Inside of the tables, try to locate 0.8907. 0.89. It's, once you start doing it, you're gonna find it very quick. See, I'm gonna say 8989. This is This is 89. You see? Is it? Can you see it? I'm gonna erase it so to do. You see 89. This is 89. 0, 89. Now you can see what Z give you that probability. What Z correspond to that probability? This is it. 1.23. So Z here correspond to this probability is 1.23. Okay, if you don't see it, let's do another examples. We're gonna go with the second example. See, we're still on the left. So look for, because they go for us, what is Z here? What Z would be? First of all, go in the table, locate. Okay, I'm gonna give you something. If the probability is below 50%, that means 0.5, then you are in the negative side of the table. Above 0.5, you are in the positive side. You see, for 0.89, because it's above 0.5, I go in the positive side to find it. Now, because the other one is in the different spot. So what I'm gonna do, we said 0.3050. 0.3050 would be here in the negative side. Let's say 0. Let's look at it again. 0.305. 0.3 0.3050. Point. Remember, I'm looking for point 3050. You know, if you can help me with that. All right, 30. It's down here. Yep, this is 3050. Okay. So what give you 3050? Yes, you can see it. It is negative 0.51, right? Negative 0.51 give you this corresponding probability. So we're gonna go here. We said Z is negative 0.51. The same way we can give you Z, ask you for the probability, we can do the same. Now, let's see. Okay, now this is what happened. Remember, we just did 2 on the left. You see, the shaded area is on the left. Now, it should be a little bit different from what you see here. Now we are on the right. This probability here, you must subtract it from 1 first. So subtract 0.9265. We do it from 1. Okay. What happened? I'm gonna grab my calculator. Sorry. I do 1 minus 0.9265. So this is what you're gonna find from false probability. This is the one we're looking for from the table. Okay. This is the one we're looking for from the table. So when we look for this from the table, look where we're gonna go with this one. Okay. 0.0725. Now that means because it's less than 50%, we're gonna go in the negative side of the table. Okay, let's do negative side of the table where we're gonna find it. Inside. Okay, look for the inside. 0.0. Let's go back. Look at it. Okay, 0.725. I just see it. I think I see 0.7. Here you go. Right there. Okay, 0.725. It's negative 145. Okay, so we know here Z would be negative 145. Okay. The last one I believe is the same. As you can see, you must subtract from 1. Subtract this number from 1. So what this one will give us, 1 minus 0.2061, it gives you 0.7939. Okay, We are on the right, so we always need to subtract that probability from 1. We don't subtract z. You see, for the z's, we always subtract the probabilities, not the z's values, okay? So now look for this one because it's above. We're gonna go in the positive side of the table. We're looking at the positive side for 79, 39, 79, 79, 39. Let's do it, 79. 79, I see it. Is that this one? Right there? It was 79, 39. Let's go back again. 79, 39. Yep. So looking at this, what you see, it is 79.82. Okay. Say probability here. So Z is 0.82. All right. Now, I think you're ready for everything else. Otherwise, like, because for us, finding probabilities is very important. The same way you could find, the Z, you can also find probability. So I'm hoping you got it because for the rest, it's just history. Because for this one, what we're gonna ask you, we said the area uh, corresponding to the region between two z-scores can be found by finding the difference between the two areas. That's what we did. We can do it in Excel. Don't try to memorize the tables. Please, you can do it directly. I put some examples. You see notation between. When you have between, so let's say for me, if I have probability that z is between A and B, for me, it's probability that Z is less than B minus probability that Z is less than A. So that's how you're going to proceed to find when it's between. Very important because we're going to do it a lot. So I showed you some examples. I'm hoping, do we have a lot? So, okay, we don't have a lot to cover. I'm going to just do one or two. Let's say for here, we said the probability that Z is less than 2.00. Because we are on the left, we're gonna go with the table. Let me grab this table because you would need this table non-stop all the time. So let's put this table here for us to see what we're doing. Again, I need to erase these and make the table a little bit bigger. Okay. Remember, we're looking for -2, -2, 0, right there, 0, 2 zeros. So this is the answer then. All you need to do, maybe you cannot see it, but I can zoom it, 0.0228. 0.0228. So, sorry about that. So, for me, giving you the opportunity to look at it that way, less than you can do it. Let's do less than 130. So if we do this one, probability that Z is less than 1.33 is the same thing. Because we are on the left, you're gonna take 1.3. This is 1.33. Let's go, 33 is right here. 0.9082. Okay. So once you understand this, we can continue indefinitely. And, if we said greater than, let's do this greater than this one. Probability that Z is greater than 2.33. First of all, because we said greater than, we need to subtract 1 minus whatever you find from the table. Greater than means you need to subtract from 1. So for us, look at this one. For us, it's like you do, this is the area where you were. You were on the left of -2. For this one, you were on the left of 1.33. I put positive out like this. But look at this one would be different because we are on the right. So 2, 2.33, 2.2, 2.3, 3 is here. 9901. 0.9901. Now we can only, all you need to do for this is to subtract from 1. When you subtract from 1, I have my calculator with me, is 0099. So for us, we were on the right. So we were here. Okay, so 2.33 here. See, on the right. If you want to do greater than as a negative number, let's say here, we said the same. Probability that z is greater than negative 2.09. First of all, you need to subtract from 1. Go in the table looking for 2.0, negative 2.0, and we said this is 2.0 here. We go 9 is right there. 0.0183. Now, if you subtract, this one, you're gonna find 0.9817. Again, remember, if you want to shade it, you want negative 2.09. Remember, 0 is symmetric about the mean, which is 0. That's why if I'm on the left, I mean, if the number is negative, I go all the way to the left. If the number is positive, I go all the way to the right. Okay. Now, if you look at the other numbers, I'm going to just do one or two of them. Look at between. If you do between, remember, for us, between, z is between 1.37 and 2.25. What you need to do probability that z is less than 2.25 minus probability z is less than 1.37. So remember, if you are on the left, you see less than, that means you take exactly what you find in the table. What do you find in the table for 2.25? Positive 2.2. Okay, let's go. What 2.2 would be? 2.25 right there. 2.25 is, remember 5 is here. So remember 2.25 is 98, 78. 98, 78 minus 1.37. 1.3. We already have 1.3 here. We're gonna just continue to 7. 91.47. When you subtract these two, when you do these two, okay, it gives us, from my calculator, 91.47. From my calculator, it is 0.0731. Here we go. All right. So you can use these examples I just did because remember the tables, you need to master the tables, and I will post it for you. So you can Google z-score tables or normal distribution tables. You're going to find it online, or look for the one I post for you. So if we go with another examples here, you see there is a different ways we can answer the exact same questions. For this exercise, we said we assume that a random selected subject is given a bone density test. Bone density test scores are normally distributed with a mean of 0 and a standard deviation of 1. In each case, draw a graph, then find a bone density that tests corresponding to the given information. So find 99. So 99 for us in this case mean we're looking for the ZE for it. Okay, so because the 99 for us, look, if you have a 99 percentile, this is the bone density. For us, 99, okay? We're gonna do 99 percentiles. We need to go with the tables again. So I'm gonna just copy the table, put it down here because as I said, we use the tables a lot because everything we're gonna do, we will do it with the tables. Now, 99.99, okay? You can look for it, okay? Somehow, I'm looking for it. The closest I can find for 99 is 0.9907 because remember, for us 99 percentiles, one is that we have, okay, 99 percentiles. I mean, they don't say if it's on the left or on the right. We're going to take exactly on the left. So 99 percentiles is like the whole thing here is 0.99. Or when I say 99, but because in the tables we cannot find 99, we find 0.9901. So the Z corresponding to this one is 2.33. Remember, if we don't find the exact value, we take the closest one for 99. Hold on. So if you go with number 2, 15, right? 15% is a very small number. So let's go for 15, 0.15. 15 means it's under 50%, so you should go on the 15%, we should go in the other side. 15%, 0.15. Let's go for 0.15. Oh, we are right there. You see, 0.15 is either this one or that one. So it's 0.1515 or 0.1492. So I think in this case, it's better we go with 0.1492 because 0.1515 is further away. So that's correspond to 1.04. So negative 1.04. If you have 15% as a probability, the Z is negative 1.04. All right, so I can leave the rest for you to enjoy as the video gonna be too long. But in the meantime, we said critical value is the line that separate these two. Let's say when we put that line in the bell shape, this critical value for us is that line. We call this line here critical value. So it separates what you are into the shaded area from not the shaded area. The standard normal distribution of the critical value is a z-score on the borderline separating those z-scores that are significantly low or significantly high. So that's exactly what we're doing. This expression z alpha denotes the z-scores with an area of alpha to its right. So remember, if we do that, then it will be on its right. For example, when we do Z is 0.25, okay? If we do this one, then know that, so 0.25, we need to do 1 minus 0.25, so that gives us 0.75. Now, when you go to the table, when you go to the Z table, because we're using the Z table a lot. Okay, when we go to the Z table looking for 0.75 as a probability, 0.75 would be either this one or that one. I believe 75 would be this one instead. Because you have two of them. This one or that one. So we're gonna pick up this one because it's closer. That give us 6, 7. So for us, Z is 0.67 for it. Okay. If you do 90Z 0.90, that means you do 1 minus 0.90, that's 0.10. Now, what Z corresponds to 0.10? Again, here, because we're going to go to the negative side of Z. Okay. We're going to go to the negative side of Z. We do 0.10. See, this is 0.10. The closest one, either this one or that one. But the closest one to 0.10 is 0.1003. So which is 1.28. This is 1.28. So that gives us 1.28 negative. Okay. So hopefully you can use these to do more exercises. As I said, remember you can use also Excel to do the exact same work in a different video. I'm gonna coming back with section 6.2 where we're gonna do real application of normal distribution. Hope you enjoy and have fun. Take care.